Don't forget to like, comment, share, and subscribe. Understanding PWHT heaters, a comprehensive guide for welders. Part 1 Introduction. Welding is an essential process in metal fabrication, but did you know that after welding, there's an equally important process called post-weld heat treatment, or PWHT? In today's video, we'll explore what PWHT is, why it's crucial, and how a PWHT heater can help improve the quality and longevity of your welded structures. Part 2 What is PWHT? Post-weld heat treatment is the process of reheating a material after welding to reduce residual stresses. During welding, metal is subjected to high temperatures, leading to internal stress, which can cause cracking or distortion. PWHT reduces this risk by relieving those stresses, refining the microstructure, and improving the mechanical properties of the weld. Part 3 Functions and benefits of PWHT. So why is PWHT necessary? There are several key benefits. First, it reduces residual stresses that can compromise the strength and integrity of the weld. Second, it improves the mechanical properties, increasing both the toughness and ductility of the metal. Lastly, it helps prevent cracking, especially in hard metals like carbon steel and alloy steel. By using PWHT, you ensure the welded structure is more durable and able to withstand various pressures. Part 4 Types of PWHT heaters. There are several types of PWHT heaters you can use, depending on your project needs. Let's take a look at a few common ones. 1. Electrical heaters. These heaters use electrical elements to raise the temperature around the weld. 2. Induction heaters. Quick and efficient. Induction heaters use electromagnetic fields to heat the material. 3. Gas-fired heaters. Ideal for large-scale applications where you need to heat a broad area. 4. Ceramic pad heaters. These are best for precise, localized heating, and consist of ceramic material surrounding a heating element. Part 5 The PWHT process explained. The PWHT process consists of 3 main stages. 1. Heating. The material is slowly heated to a specific temperature, typically between 500 C and 750 C, depending on the metal. 2. Soaking. The material is held at that temperature to ensure the heat penetrates evenly and relieves internal stresses. 3. Cooling. Finally, the material is cooled down at a controlled rate to prevent sudden changes that could lead to cracking or warping. Part 6 Real-life application. PWHT is widely used in industries like oil and gas, power generation, and heavy machinery. For example, welded pressure vessels and pipelines often undergo PWHT to ensure they can withstand extreme conditions. Here, we see a large steel pipe being heated after welding. Thermocouples are placed along the weld to monitor the temperature throughout the process. Part 7 Temperature control. Temperature control is critical in PWHT. Using thermocouples, we can ensure that the entire weld area reaches the target temperature and maintains it for the required amount of time. Modern PWHT heaters come with digital control panels for precise temperature adjustments, making the process more reliable. Part 8 Safety measures. When working with PWHT heaters, safety is paramount. Always ensure proper grounding, wear protective gear, and monitor the heating process closely to prevent overheating or equipment failure. Part 9 Conclusion and recap. To sum up, post-weld heat treatment is a vital process in ensuring the durability and strength of welded structures. By using the right type of PWHT heater and following the proper process, you can prevent issues like cracking, improve the material's mechanical properties, and ensure long-lasting results. Thanks for watching, and stay tuned for more videos on welding and heat treatment techniques. Part 10 Call to Action. If you found this video helpful, don't forget to like, subscribe, and hit the notification bell for more content like this. Let me know in the comments what other topics you'd like to see covered in future videos. Thank you.